This is Kumar, Assistant Professor. Today I want to discuss about HF, VHF and UHF antennas. So in that, one of the most important concept, Aggie-Wood antennas. In exam point of view, the questions comes like this. Write detail about Aggie-Wood antenna. It comes 2016 advanced supply paper, and draw a neat diagram of an Aggie-Wood antenna and explain its design procedure and applications. It comes regular 2014 paper. Explain operation of Aggie-Wood antenna. What are its advantages? It comes 2011 paper. So Aggie-Wood antenna is one of the most important question in exam point of view. So what is Aggie-Wood antenna? So Aggie-Wood antenna is a fourth classification of antenna. So there are four classification of antennas. In that fourth classification of antenna is a Aggie-Wood antenna. The range of Aggie-Wood antenna is 30 megahertz to 3 gigahertz. It can be used in VHF and UHF bands. So the Aggie-Wood antenna was developed by Professor Aggie and Wood. So both professors was developed by this antenna. It consists of one active element. So this is called as active element and few non-active elements. It consists of one active element and few non-active elements. Construction of Aggie-Wood antenna. So how we construct Aggie-Wood antenna in detail? So by using one supporting rod, so the active element here used as folded dipole. The folded dipole is used as a active element in this Aggie-Wood antenna. So beside of this, the reflector was placed. The reflector is placed beside of for active element. In front of active element, the director was placed. Here the director and reflector is called as non-active elements, and the folded dipole is called as a active element. The length of active element is lambda by 2, and the length of director is less than lambda by 2. The length of reflector is greater than lambda by 2. Features of Aggie-Wood antenna. It consists of driven element. So driven element is also called as active element. So active element, here we are using folded dipole. So here the folded dipole is used as a active element, as well as a reflector and more directors. Depending upon directors, so the gain requirement, we can place directors. The driven element is consist of folded dipole, which is length of lambda by 2, and the reflector is length of greater than lambda by 2. It is located behind the active element. The length of director is less than lambda by 2. The place of the directors in front of active element. The number of directors depends on gain requirement. So if you want to more gain, if you want to increase the gain of antenna, we can place number of directors in front of active element. The impedance of active element is resistive. The impedance of reflector is inductive. The impedance of director is capacitive. It is used as a transmitting antenna in HF and VHF bands. The more directors can be used to increase the gain of antenna. It has good front to back ratio. Front to back ratio means that the radiations, moving of radiation efficiency is more. So it has very good front to back ratio. Whatever the half-wave dipole, so the dipole has radiation moves front as well as backward. So backward and frontward. So that's why it has very good front to back ratio. The bandwidth is limited. The bandwidth is limited. So mostly this antenna is used for TV antenna. So to receive number of TV channels, this antenna was used. It is most popular used for easy to use and easy to perform and easy to maintain. So that's why the Aggie-Wood antenna is a very familiar antenna. The advantage of Aggie-Wood antenna is it has high gain, it has high directivity, and the handling and maintenance is very easy, and less amount of power was wasted. And to receive number of TV channels, the radiation pattern of aguda antenna is mainly only one direction. So the direction of aguda antenna is mainly one direction. So only one direction the radiation is maximum, and the alternative direction is minimum. And so the pattern comes like this manner, and the designing equations are: length of active element is 478 feet by 478 by frequency. How much frequency we can use? So by using that frequency we can measure length of active element and length of reflector and length of director, as well as spacing between the elements. Those are designing equations. Students, if you have any doubts, ask me in comments section. I will upload notes also. Thank you. It is nothing but a real-time aguda antenna. So it is 5-element aguda antenna. So why it is called as 5-element aguda antenna? Why? Because it has 3 directors and 1 active element. So here this is nothing but active element. So it is a folded dipole, and 1 reflector. So this is nothing but a reflector. The length of folded dipole is lambda by 2, and the length of directors is less than lambda by 2, and the length of reflector is greater than lambda by 2. So if you observe carefully, so the length is slightly less than compared to reflector. Folded dipole is less than slightly less, and compared to folded dipole the directors is less. So this is real time antenna.